Scene transitions are a great way to hide loading details from the player, and also to give some personality to your game. Implementing such system could be challenging and painful, especially if your game is packed with a lot of scenes. In this video, I'm going to show you how you can implement a custom, global, maintainable transition system that can handle any request from anywhere all along in your project. We are also going to cover how to create 3 different variants of transition to have some base ideas how to create your own custom ones. All the project files and source codes are available on GitHub. Link at the description. Let's see the basic idea. Instead of individually implementing the transition system inside of the scenes, we are going to use a global transition manager. The manager has its own transition layers, which we can access from any of our implemented scenes. We can use these layers to hide transition details from the players while entering from a scene to another. For demonstration, I'm going to use this simple project with 4 scenes. Nothing functional, only presentation. We have one script to deal with, which is the SceneLoader. It has only one function to load scenes, but we have to improve it because it's impractical to load the scenes on the main thread. It could cause freezes in case of massive scenes. Instead, we are using a coroutine to handle the scene loading asynchronously. First we disable the activation, then wait until it's done, then re-enable it. Also, this is the place where we are going to put our transitions. Let's replace the old one and save the script. Because of this project is so small, there is no sign of visual improvements, but we're on the right direction. Now let's create the earlier mentioned TransitionLayer script. Delete the unnecessary code. TransitionLayer is an abstract class with the following properties. One value to monitor the progress and one for the state. We define also a callback property. Let's define 2 pairs of functions, one for showing and one for hiding the transition layer. And finally, we are going to implement the callback invocation function. Don't forget to include the missing namespaces. Let's define our first transition layer variant, the FadeTransitionLayer. Delete the unnecessary code. Extend it from the TransitionLayer class and implement the missing functions. We are going to use a canvas group to control the opacity of the layer and a coroutine to store the transition process. Set the canvas group as a required component. Let's cache it inside the awake function. Now I'm going to implement the transition process that's going to dynamically change the alpha property of the cover layer. At the end of the coroutine, we are going to call the invoke and clear callback function that we are already implemented earlier in the transition layer. I'm going to implement the opposite coroutine of the show process. In the end, I'm also going to disable the game object itself and invoke the callback function. Now let's utilize our newly created functions. We're going to set the default values and store the transition. Same with the show function, and we're also going to enable the game object. Also, don't forget to call the correct coroutine. Now let's define the immediate alternatives. We set the terminal properties and also terminate any running transition. Let's define the simple function. Since it's a private function, we are going to move it a bit below. In the function, we are going to stop any running coroutine and set all the terminal values of the layer. Same applies for the show immediately. Save and go back to Unity. We're going to test how our new layer is working. Create a new image UI element. Set the size of the image to cover the whole screen. And select custom color. Finally, add our transition layer, and as you can see, the canvas group is automatically added because we defined it as a required component. We can disable it for now. And just to test it out, we are going to create a reference to it inside of the SceneLoader, which is a bad idea, but we are going to use it only for a short duration. Let's call the show function of the layer with some custom constants. We are going to add the status of our layer inside of the condition. So one process has to wait the other. Just for now, we are going to exclude the fade out animation. Now back to the scene, and let's wire up our SceneLoader and see does it works as we intended. There we go, the transition is working, but we are missing the other half. That's why it is switching too suddenly. But we can't just call the fade out function yet, because of the transition system only working locally inside the menu scene. Soon we are going to solve this issue. Now in the following, we have to install the addressable Unity package to instantiate the global container that's going to store the TransitionManager. Current version is 2.2.2. Now let's create the container initializer, the SystemInitializer script. This is a static class with a single init function. We're going to add the runtime initialize attribute to ensure that the function is called when the game is starting. Inside the function, we are going to initialize our container, which bears the system label. We are going to use it to find it inside the addressables. Then give it a more recognizable name, and finally mark it as a don't destroy and load. Back to Unity, create an empty game object. Name it as a system and create a new prefab out of it. We can delete the original one. Now inside the inspector view, check the addressable checkbox to add the prefab to the addressable system and make sure to give the same label as we defined it earlier. And from now, the system container is automatically loading every time when we enter play mode. Now we are going to create the transition manager to handle all the transition requests. Delete the unnecessary code. Since it's going to be a singleton class, we have to hold a static reference to it. To actually utilize the transition effects, we have to define TransitionLayer property, which we're going to cache in the awake function and initialize at the start method. Now let's replicate the same fade layer inside our system container. Add a new UI image to the system container. We are going to set up the correct resolution of the canvas. For the image, make sure its size is as big as the screen. Choose a color and add the transition layer. Now we just have to add our transition manager to the system container game object. With that, all the setup is done. Now we can delete the old transition layer. Now only things left to corrugate the SceneLoader class. Remove the old reference. Instead of that, we are going to use the transition manager instance to access the transition layer. And with that, we can finally call our fade out transition. We have to call it after the scene activation. There you go. This is the final moment of truth. And as you can see, The transition system is working all over the project without modifying any existing scene. I hope you can see the power of this solution. Now let's see the other variants. Create the new TwistTransitionLayer script. We're going to borrow the code from the previous implementation inside of FadeTransitionLayer. Don't forget to extend the class and to import the missing namespaces. Instead of the canvas group, we are going to use a rect transform in this case. Make it serialized field since we are going to assign it inside of the editor. Now instead of the alpha property, we are going to modify the local scale and rotation of the cover. First we apply the terminal states inside the immediate functions, delete the unnecessary code. Then we're going to change the coroutines to progressively change the rotation and the scale of the cover. Don't forget to set the terminal cases. We're giving the same treatment for the height tween. Back to Unity, we have to create a new layer inside of the system container. We can temporarily disable the old one. Make sure the container is overlapping the screen. It's going to have a transparent image to block the raycast, but not the view. Add the twist layer, and now we have to create the missing cover. The cover is going to have the exact site as its parent. Set its color and disable the raycast target, since we are already blocking it inside of the parent. Now we can assign it. Let's test it out, and as you can see, it's working without any issue. For the pixel diffuse effect, we are using a custom shader graph, which you can download from the project files. Create a new script and name it as PixelTransitionLayer. Delete the unnecessary code, extend the class from the transition layer, and copy the implementation from the FadeTransitionLayer. In this case, instead of the canvas group, we are going to use an image and the material to modify the visuals. Set the image as a required component for the class, and to set up all the references inside of the awake function. On enable, we have to set up the correct aspect ratio of the material. This is crucial because otherwise the shader graph pixels might get stretched. Instead of the alpha value, we are going to set the material's visibility property. Inside the tween, we are going to replace the alpha with the material's visibility property. Now back to Unity and create our last example. First, disable the twist layer, add a new UI image, set its size to overlap the canvas, and add the corresponding transition layer. We are going to give the pixel desolvation material for this image. You can play around and tweak the shader values to find your best fit. Now we can enter the play mode to test it out. As a final improvement, inside of the manager, we can replace the layer with an array of layers. And now we can access multiple different layers at once. For the SceneLoader, we are going to expose the following values. We can use a target layer to specify which transition effect we are going to use. And instead of the constants, now we can use the fields to modify the duration and delay of the transition. Inside of the system container, now we can enable all the layers. We can tweak the values to find our best fit. With this modification, we can add different variants of transition for different scenes. Just change the target layer index and we are good to go. That's it for this video. I hope you enjoyed it and found something new. Cheers!